Today I've been doing some research into building decentralized apps. My name is Bulent Tastent, I'll say it in Turkish. It's a common Turkish name, but not common here. So we'll talk about building decentralized applications, and I'll give a description of like from technical perspective and also business perspective, so that it's not it's understandable from both sides. So my background is I'm a software engineer myself. I have a computer science degree. I worked at big tech companies like Microsoft, Amazon, and then Facebook. I have back-end and front-end experience. And last 3 years, I've been running my own startup. And I actually am an expat from the Silicon Valley. I moved here recently. And I want to ask people like who here I have like 4 questions. Who here have JavaScript experience? Okay, that's good. Who have blockchain experience? Or who knows blockchain? Who knows blockchain? I don't like. Okay, what about decentralized applications? Okay, good. At least some people know. That's really good. So we're going to talk about blockchain first. I don't want to jump straight into decentralized apps. I want to explain like at a high level what's a blockchain, and then discuss some of the things. And then we talk about decentralized apps, how to build it, what that means, building an app there. And then we'll talk about a very simple app, voting app. So it's between a couple of candidates, you vote for one person, and then we show the results at the end. And then we're going to do some testing, and then at the end we'll talk about, we'll discuss, open to brainstorming about some of the possibilities and current trends in blockchain. And maybe you guys can chime in on that. So what's a blockchain? Because the crowd is technical, I wanted to start with a technical explanation. So it's a write once and read only database. It's as the name says, it's a chain of blocks. So each block holds multiple transactions. Is it my microphone? Each block holds multiple transactions, and the blockchain itself holds user accounts where it actually belongs to you, and no one can tamper with that. And also it stores transactions. So everyone sends their transactions. Let's say Alice sends money to Bob, and then Bob sends money to David. That transaction set goes to one block, and that's stored, and everybody in the network knows about it, so that when you look at the transactions, you know if there's a problem or not. So it keeps us like a kind of to make sure that nothing is tampered with, and nothing is changed. And each block is secured by a cryptographic hashing, so that the hashing algorithms make sure that the data within the transaction hasn't changed. And then this is validated by a set of computers. So when the transactions are sent as a new block, every computer running that blockchain will receive that set of transactions. And then they try to use a consensus algorithm. In Bitcoin's perspective, the consensus algorithm is a proof of work. So it runs a reverse mapping from hash to the actual value. And then that takes a long time to make sure. So it proves that you actually did the work and committed to it. And in other blockchains, the consensus algorithm is proof of stake, meaning you put in your own money to be able to participate in the consensus algorithm. So which means that you want to make sure that the transactions, the process of adding a new block is accurate and correct, because you have involvement in the process of creating the new block. So this allows the network to validate and just function and make sure that every transaction, every block is processed correctly. As long as 51% or more of the computers participate in the truth of the new block, then the blockchain continues very accurately. From a business implication perspective, blockchain allows people to exchange anything of value. And I was describing to a friend, let's say you want to, this can be anything of value. Let's say you want to transfer something to somebody else, and you don't want any third party to be involved. This using blockchain, you can the person can put it, and then the blockchain will run as an escrow service to make sure that the transaction has happened. And because we know that the transactions are correct from block to block, the people looking at the blockchain will make sure that the transaction actually happened. So you don't have to trust someone that it actually happened or not. You can just trust the network. And this the blockchain itself acts as a public ledger. So we see ledger in banking as a banking term. And the transactions, the terminology of transaction is actually makes sense because it basically keeps track of who sent what to who. And then if you aggregate the entire block sequence and aggregate all the transactions, you get at the end the accounts and the holders and then the amounts in their accounts. And that acts as a public ledger. So if someone is sending a non-existing amount to somebody else, everybody in the network will point that, hey, you can't do that transaction, and they will cancel that block or cancel that transaction. Mostly the transaction only will be canceled. The block will continue. So you can think of it as like, in technical terms, you can think of it as like a database, basically, a public database. And then the other implications is trustless. Normally, let's say you purchase something from Amazon, and you know there's a trust between Amazon and then the consumers. You know Amazon is not going to screw you over. You know Amazon is going to send that product. And you know when you send it back, Amazon is going to take it back and give your money back. What if there's no government, there's no organization, and you want to build that trustless system in some way? What you do is you basically have faith in humanity. So blockchain has like this faith in humanity and creates this trustless system, but everybody trusts the network. You don't have to trust an individual or a government. You just trust the network, and the network it acts as a kind of your third-party service. Some examples are, if you think about like public ledgers, you can think of like a hospital medical records. So medical records belong to a person, and you want to give access to a hospital yourself. So you can keep the private information of the medical data, and then you can give a hospital the access, and that way the transaction between giving the information to a hospital is between you and the hospital, no government or any other third party involved. So another example is shipment. Because this is a public ledger, you can, let's say you're sending a laptop from manufacturing and all the way to the customer. And so along the way, when there's an additional parts added, you can keep track of these in a public ledger. That way, if something is missing, you can always look back and see what was missing. And then no one can say, hey, I saw that, or I didn't see that. It's clearly written on the public ledger. So it's great for a use case for logistic services. Voting is a good example, but I mean, voting involves other things too. So obviously, there's other things involved for voting, but just to keep track of who voted, and then the votes are counted once, and that sort of trust can be achieved by a blockchain. Obviously, voting has other things involved too. And then the contract. Let's say everyone has a LinkedIn account. You say, I'm graduated from this school. I worked at these companies. But how do we really know you actually graduated from that school? So we don't really know. We just trust you basically. But we don't have to. With a blockchain, a school can provide that certification give that certification to a user, a person, and that person will be able to carry that over and then show it to people, and then anyone can look up and validate the truthfulness of that certification. And also CryptoKitties. So if anyone wants to own digital goods. Might have switched to, yeah, there you go. So, okay, so that's blockchain. What's a decentralized app? Decentralized app is sort of a kind of a microservice backend. If you are familiar with microservices, it sort of acts like a microservice backend. It's similar to, and the way it works is similar to like turn-based games. So in like a poker game, everybody makes their move, and then the turn moves on. So think of each block as like one turn, and you make your transactions, you call, or you make your move, and then you deal, and then go to the next block. So think of it that way. So when you build an application, the mindset is that, okay, there's like a database where anyone can see, and I can write to it, but I have to like wait everyone's turn and then go to the next block. So if you think of it that way, it really helps when you build an application. And then the public ledger itself is your database, so you can store any kind of information. And you write smart contracts like on Ethereum, or there are other ones too. The smart contract is your business logic, where you can have rules or other things, other constraints, and those pretty much the business logic of manipulating the database happens in a smart contract. And then the smart contract itself, and this is different between different blockchains. In Ethereum, smart contract itself holds the account and balances for different people. In other blockchains, Solana, actually the account and that data is held within the account itself, separate within the account. But in Ethereum, the block smart contracts holds the amounts and all the transactions and who sent what, keeps track of that data transfers too. And I'm going to go into Solidity. So Ethereum uses a language called Solidity. Actually, at first I thought it was very hard, and it was like the name Solidity, I have to learn a new language. But actually it's just similar to JavaScript. It's very, very similar. There are a couple of inventions in there because of the restrictions of blockchain. For instance, you don't have a while loop. You have to know your loops exactly how many times. And then a couple of like memory issues, because you can't, the way you store data has to be very clear and accurate and deterministic. Because of that, there's some restrictions. But we'll go through it. But let's take a look at our app. So the voting app, our idea is that we want to create a set of candidates, and we want to vote on a candidate, select, and then count how many votes have been done. And then we want to, not only that, we want to protect the candidate and also the voters, that you can't vote twice, and then make sure that you vote on the right candidate. You can't just randomly vote on a non-existing candidate. So we're going to build this app very simple, step by step. And the way it works is, so let's start from here. So you have your smart contract, and then the ledger, the data is in your blockchain. And then you have an interaction with, so the smart contracts usually provide a JavaScript SDK, which allows you to open a connection and then send the account information, send the transactions, and then listen to events that return back. And then that goes, the information is shown to the user. So for this one, we just need, these are the technologies that I use, and very useful stuff. Ethereum is pretty developed at this point, so there's a lot of tool chain and tools to help developers build. Node.js, you run your website. It's a JavaScript runner. If it doesn't know it, someone doesn't know. Truffle framework acts as like a middleman. It helps you with the Solidity framework. It helps you compile and run things and deploy things. So it really is very helpful. Ganache, I think, it acts as a local node. So it runs as a local Ethereum node. And when you're developing, you don't want to send your local small changes to the actual network. First of all, the actual network costs money. And then second, it takes time, at like 3 minutes or so from each block. So this acts as like a local node. As soon as you run a couple of things, it just blocks move quickly. So it helps you develop. And Metamask is the crypto wallet. The Metamask is actually, it can be used for real crypto, but you can also use it for like local crypto. So it's a Chrome extension. What happens is it injects some of the Web3 SDKs, like Ethereum SDKs, into your code, so you can interact with the Ethereum network directly through your browser. So it not only acts as a wallet, it also injects so that you can access your wallet information through the website, with your permission, obviously. So for the functionality, we want to write a smart contract with read-write candidates. And we want to list the candidates. We want to keep track of votes, and then enforce some of the voting rules. So list candidates, we want to list them and show the number of votes. And we want to be able to vote, and then also enforce rules. 3 things we're going to implement. So let's talk about the basic, what a smart contract looks like. So at the top, in a smart contract, you specify your version for obvious reasons, because smart contracts language changes too. You start with just a text contract, and then you specify the name of your contract, and you specify inside. It's like a class, pretty much, a JavaScript class, and you specify any public variable specified within your contract is actually stored in the database of the blockchain. So when every node in the world, when you specify this, it actually is in their database. The logic is in the functions. And in your constructor, this is run only once when you deploy. We're going to go, and this is just a very simple, we're not even going to use this, we're going to use something else. But let's go to our candidate, like how do we create our election contract? So for election contract, we want to keep track of candidates and their information. And also we want to make sure that we keep track of the votes. And also we want to, additionally, we have this. I'm going to explain why we need that. So for, who's familiar with this term, struct? Yeah, okay. Is it, what language is it in?
It's in C, C#.
Yeah. Swift. So this is your model, basically. A candidate has an ID, a name, and a vote count. Very simple. In C, I think C++, you see these like specific number of bytes or bits. So when you do contracts, this is 256, but by default. But when you write, you want to make sure that you have the exact, because these are going to be stored in the database and it costs money. Here we keep track of candidates, and we give IDs like starting from 0. Actually, you want to exclude 0, but that's not too important. So you keep like ID number 1 is actually that candidate. So it points to a candidate and its information. And the one thing in Solidity is that you can't go through a list of maps. So mapping acts as like a hash table. You cannot go through the list of your hash table. So it's not allowed. Because of that, you have to internally keep track of how many candidates or how many things you have in your array or in your map. So we keep this candidate count so that we can loop through them. And then we also keep track of votes. And this is a very specific term, address. Address is actually an account. So when I vote, I'm voting from my personal account. And I send a fee to make sure that vote counts. And then it only keeps track right now for a basic example, if I voted or not, whether I voted or not. So, so this is our data structure. And when you build this, the Truffle framework, Truffle tool system, gives you a JSON file, creates a JSON file, and that is like, if you use RPC and things like that, there's always like a file that describes the methods to call from the JavaScript. So otherwise, JavaScript wouldn't know what to call or wouldn't know how to validate. So this allows it to, it's sort of a blueprint of your contract. So we load that file and we create the contract, and then we go through, we get the candidate count, and if you notice, there's an await, and that's because the interaction with the blockchain is always asynchronous. And then you go through a number of candidates, and then you loop, and then you just render them, basically. So you get this. So candidate 1 and candidate 2 votes are 0, and then the IDs. So you get that. We haven't voted yet, but this is a good start. For voting, let's take a look at the code. So it says function vote a candidate ID, and it's public. So usually in languages, public comes first, but in Solidity it's here. And return type is also after this. We do have a required built-in function. It checks, it does assertions to make sure. So here we make sure that the voting for a valid candidate. So it should be over 0, and it should be less than or equal to the candidate count. And then we can do more checks, like you voted once or things like that. And this variable message is a special variable. It's a special variable. It holds the information about the caller, and it's the information about the account information, and if the person paid money, or if and things like that. So it comes to the function directly. So what you do is, and it's the sender variable is an address type. So you set the voters of that to true, which we saw earlier. And then you also increment the vote count for that candidate. And then the voting comes from a specific ID. So your person has to select which person to vote for. Any questions still here? Is it clear so far? It's quite simple. Obviously, you guys probably write way more complex code. So let's take a look at the website part of it. So that was our contract. And on the website, we have a form. Let's create a form, and then when you submit the form, we'll do a cast vote. And in the form, we have a drop-down of select options, and this is typical like HTML. And there's more stuff here, but I truncated it. So when you cast a vote, obviously this comes from the value of the option, which is auto-generated in the beginning. And then you send that vote, you call that vote method, and then with the candidate ID, and then you say that it's coming from me. And then in the app, we can always check for voters, and because our account is also an address, we can see if we voted, the user has voted. That way we can show different UI to the user. And so you get this form, which shows multiple drop-down options of each candidate. And then you hit vote. After we vote, we check we can check if the person has voted, or we can kind of hide that area after that. So when a person votes, that creates a transaction. Basically, what you do is you go to your wallet. You say, "Hey, I'm going to vote. I'm going to call this function." The wallet doesn't know what you're doing. It just knows you're trying to make a call to this function, and then you send the ether to make sure that the function actually goes through. That ether, the small amount of ether you send, is a way for the network, the computers, to basically an incentive to process your function call. So I will show you later how to use it. and it just basically that Ether you send, let's say $5, will go to, and then other transactions too. And then the fees are all collected, and then the computer that processes that block first receives all that Ether, and it keeps that. And then every computer knows about this. So, but this takes a lot of time. So it could be 3 minutes, could be 10 minutes, could be a second. So we don't want the user to wait. So what we want to do is basically, when the transaction is complete, we want to be notified. So this Ethereum, the Solidity comes with like notification, kind of a pub/sub system, publication subscription system with events. And you can get notified. And you have to, and then you emit this, so you define what the event is like, and then you actually call and emit the event from within your code. So this could be, as soon as anyone votes, we can, because we want to refresh that UI and then somebody voted, we want that count to go up automatically, we can just emit that code as soon as someone votes. After that, we can just emit that vote for that candidate. And then the UI side, we can have, this is our Web3 instance. So we can listen to it, almost the subscription part. And then for voted event, which is the same name, and then you can specify from how much time you want to listen from. And this is obviously not optimum, but you can think of like keeping a session or something to keep the last block, and then you keep updating to your last. And then what you do in our simple app, we can just re-render, because rendering will probably refetch all the candidates and then show the vote counts. So I'm actually let's show you how this works. All right, let's zoom in. Okay, so let's refresh. So what happens is I'm running a local node here. This is all test data, so don't worry about these numbers. So when you run this, it gives you 10 accounts and fills them with 100 Ether. It's funny to say because now it's so expensive. And then it does auto mining, meaning every time there's a new transaction, it just runs another block. So you can kind of see all the blocks that are happened. So I've been running this for a while, so I have 168 blocks. And in each block, you can see all the transactions. Some of the transactions are like creating a contract, some are calling the contract, and even you can transfer amounts to people. And so I'm going to refresh. So I want to choose maybe candidate 2. When I do vote, it should pop up my account. And this is where the Metamask comes in. So Metamask gives you notifications, hey, do you want to run this vote method on localhost? I say, with this amount, I say, yeah, confirm. As soon as I confirm, it's happened so fast, but it actually reads the blockchain again and gets all the votes and then hides the information because I can't vote again. So if I refresh, it knows that I actually voted before. If you I actually try manually, you can write tests. I didn't go into testing this.
So are you resetting every time while you're testing?
Yeah. So yeah. So good question. So there's a way to reset in Truffle. So basically, get rid of all the contracts. Yeah. So everything starts from 0. But if you're not, you can't build because it knows that you're there. You have to refresh it. Yeah. But in real world, you can't. So you have to. So that's a good point because when you send your contract, it's one time. It's read only. So you cannot update your contract. So it's not like you go to your backend code and you send a new Git commit and then it goes through CD or whatever. You can't update your code. You can update your code. It's just that you can only disable your code. So the way people use updates of version smart contracts is there's a disable function. They add a disable function. They disable the whole thing, and then create a new contract and carry over the data from the previous contract, and then just carry over, start from that, and then just that will becomes your next contract. And so your website points to that after that. Yeah. So it's a big. You have to really consider that. Yeah. Any questions?
So the code exists in the blockchain.
Yeah. So yeah, that's a good point. Yeah, the code is actually in the blockchain too. Yeah, which makes it an interesting point because you can see everybody's code. There is a way to hide your code. The concept is called an oracle. What happens is basically your smart contract acts as a proxy to your backend service, and it acts as an oracle. So there's like 2 hops. Instead of 1 hop, there's 2 hops. And then the oracle, your hidden code, will send the data back, and then you send that information back.
And who's the oracle?
What is it?
Who is the oracle?
Oracle is something you build or you specify in the contract. You say, go call this guy, and then like a lambda or any backend service you can write. Yeah. But the blockchain code is available, basically. Well, the byte code is available, but you can, I think the term is deobfuscate, so you can get that code back. Some of the possibilities, and these are some of the things that are happening new, which is really cool. Selling NFTs. NFT stands for non-fungible token. So the difference between fungible and non-fungible is a fungible token, just one difference is it can be divided. So let's say you have some Bitcoin, you can send a piece of that to somebody else. With non-fungible, you cannot divide it. You can send the whole thing or not, basically. That's why you can assign these things to a digital good. That way, when you send the ownership to somebody else, the whole entire digital good goes to that person. It belongs to that person. CryptoKitties is one of them. There's a lot of good examples. E-commerce, marketplaces, so it's good for like logistics and tracking what's being sold. Decentralized autonomous organizations, these are really cool. What it is basically the governance of an organization is done through voting on blockchain. Let's say we have 3 topics for next week, and then you guys all have coins, like Gem3 coins, and then we ask you to vote on which one we should present. And then you go home and you go from your Metamask, you vote on things, and it's clear. Everybody can see who voted, so that we don't get, the organizer doesn't get to choose. It kind of democratizes the governance of any organization. And that's called Decentralized Autonomous Organization. This is very cool, very new stuff. In gaming, so the combination of NFTs and other things work really well with gaming. A new concept of play to earn concept is very popular these days. The idea is that you have your NFTs, you have like one of those card games, but the more you play, the more coins you earn, which you can redeem later. And so you might think like, okay, well, I don't want to earn that much, but you might think there are people who play games just to earn money, and this kind of almost democratizes like the gaming industry. In some countries, the earnings they get from these coins is enough to live off, and so there's a lot of development in that area. Actually, I'm very interested in this space.
Is that something like an engine token, engine coin, and
Yeah.
Axis Infinity?
Yes, exactly that. Yeah, Axis Infinity is exactly my example. So Axis Infinity is like kind of a turn-based game. You have your own characters. The opponent has characters. You have advantages. You pick your cards and you play against, and it gives you SLP or some token, and then you can redeem that token later. Yeah. And then incentivizing content creation is, journalism has moved to people creating content, but there's not clear incentivization. So this allows content creators to be able to earn money directly. Like let's say YouTube views, you can earn 100% of your money directly. So much fun? Yeah. DAI coins, attention something coin.
That settings code?
Yes, basic attention. Yeah. Basic attention token, right? Yeah. So.
They're making money with this too.
Yeah. So I mean, for like a small use case, you're not going to earn that much. But if you spend your day, you're actually going to make some decent money.
Before you leave this slide, it's got a subtitle.
I needed to hit the play button.
The purpose of sort of possibilities of using this in the industry. So complete that sentence. Possibilities of what? Possibilities of implementation.
Possibilities of use cases of blockchain. Yeah, so, and this I wouldn't say there are things you don't want to use blockchain for. If you want to use a centralized system service, you don't want to use blockchain. Blockchain is not for everything, but it's also great for certain things. It's a great fit for certain applications. So these are like some of the possibilities, and also kind of experiment in these areas. These are very new areas in blockchain, and a lot of people are experimenting in these areas. So especially DAO is one of the newest ones. DeFi, Decentralized Finance, which was 2019. Decentralized finance is basically you have some sort of money, some sort of coin that has value. You put in your money, and then you earn annual increments from that. Yeah, interest. Yeah, exactly. Do you want to explain? Go ahead.
No.
Sorry, put you. Yeah.
You take your crypto and you earn interest off of it. You just sit it in there and you loan it out. Yeah. And when you loan it out, you get revenue from your.
It's a short term, right?
Yeah.
Also, it's a good thing.
Just like lending a stock.
Yeah, exactly.
Well, the difference in that is that you could take like people don't want to use their crypto. For instance, who wants to go to Burger King to spend Bitcoin?
Yeah.
So what you could do is link it to Aave or a compound.
Yeah.
And you could take a loan out on your own money, but your crypto keeps growing.
Yeah.
So you're still sending more crypto there, and it grows. And you take that out free and give it back. It's
It's just like savings account.
This is
The percentage.
better than savings account.
Yeah.
You can actually use the money, and this money's growing. Your Bitcoin growing. You take a little bit out here.
Yeah. So it allows pretty much everyone get involved in decentralized. I mean, basically, compound interest, in getting interest. Yeah.
But what it doesn't take away is you still have to have a trusted partner that is your bank,
Yeah.
right? So there have been some very bad cases in DeFi.
Yes.
So the guys go on bust. So it's like, banks go under, and especially online banks go under, and especially anonymous online banks are notorious. That's true. That's all this really is, right? It's banking.
And it's a risk-reward situation. Because of that, right now, the interest rate is at 0.5 on USD savings. It was, I think, 2% at some point last year, 2 years ago. But like crypto, you get like 8%. But it can go down. I mean, it's a risk you have to consider. You can lose it all, yeah. Of course.
If the bank goes under.
Yeah. Yeah.
I guess, my point is like, or you may have mentioned it, just like how is the account tied to the person?
Yeah, so in the examples I gave, you can create as many accounts you want, and no one will know they're yours. And you can send your money to 10 accounts and then send by one. But there are blockchain applications, like decentralized applications, that provide ID, like it's you. That's all it does. So what you do is you use that application, you use that smart contract to verify a person, and then